Hello everybody, welcome to episode 3 of the CSGO multi-hack series. In this episode we're going to be making a bunny hop for CSGO. This series we're going to make a lot of things and it's going to be really awesome. This will be all back undetected. In the very last episode I'll go over how to do that. We'll combine all the little things we make into one massive multi-hack. The code will be available on gamereversal.club along with a free download of the .exe. And there'll be new episodes every week, so go check out the playlist down in the descriptions for the other episodes. Before getting into coding, I would highly recommend disabling Valve anti-cheat back just to develop safely because you don't know what's going to happen. It'd even be best to just make a second Steam account since CSGO is free just to test on and all of that. Alright, so for our IDE, I'm going to be using Visual Studio 2017, Visual Studio Community 2017. You can use 2019 if you haven't installed it yet. I'm just still on 2017 because there's really no difference between the two versions. But we're going to head up here to File, New, and click New Project. Now here we're going to select Visual C++ and select an empty project. Empty project, we do that just because we want to avoid the annoying precompiled headers. Alright, let's just name this. I'll name this Bunny YT and let's create the project. Alright, everything should look empty like this, so come down to source files, right click, hover over add, and click new item. We're going to add a CPP file, so click on that and click add. Alright, I'm going to zoom in here just so you guys can see easier. Now let's include our preprocessor directives. Right here we have IO stream, windows.h, which is where we're going to access read process memory, write process memory, and that type of stuff. T1 help 32, we're going to be using that preprocessor directive for things like getting the module base address. Alright, let's do the defines right here. So we have three things we're going to be using, two addresses, these two, and one offset. Now do keep in mind if you're copying and pasting this code from the gamereversal.club website that these may be out of date. So the best thing to do is to head over to Haze Dumper. This is what I'd recommend most. Just select this, whatever you're looking for to update. Do Control F and search for it, and then you can get the updated values. Do keep in mind though, it does take a day or two for Haze Dumper to update. You can dump the offsets yourself and get the updated ones, but I just really don't use CSGO that much, so I don't have my own dumper. Alright, let's start defining, or declaring, our global variables. So uint pointer underscore t, this variable type, or data type, we use this because it can be used to store addresses for both x86 and x64. Speaking of the architecture, make sure you have this set as x86, as well as you come over here and right click on your project and go to properties. You have this character set as use multibyte. Now keep in mind for 2019 this will be under the advanced little slab right here, but it's all there. So we're going to name this module base. Our next one is going to be a D word for proc ID, same thing as process ID, and do make sure you have the capitals the same as this. We're going to have a HWND, and this is just going to be used for storing the window. Then we're going to have a handle, and we're going to call this hprocess. You can think of a handle as like a tunnel of communication between us and the thing we're hacking. Now this next function we're actually going to be pasting in because it is kind of lengthy. Oh, and right here, this needs to be lowercase on proc ID because we do reference it like that. You can paste this in. What this does is it gets the module base address of whatever module we give it. So that is really nice. We do use this a lot in the series. And again, code will be on gamereversal.club. Now these next two templates are going to be the last things we're going to be pasting in here. These templates just make using RPM and WPM easy. RPM is read process memory, this function right here, and WPM is write process memory, this function right here. This just simplifies the whole process for us. It is optional, you can work your way around it, but I just like to include that. Alright, so let's actually do our int main. This is where all the code will be. And here we can do hwnd equals, now find window A, we're going to use this function. And what this does, it will just essentially store the window so we can reference that later to get the process ID. Now I'm going to paste this in here right here just because I want to make sure I spell it right. And if you do notice, this is the name of the window of Counter-Strike, Counter-Strike Global Offensive. Alright, next we're going to use a function called get window thread process ID. And this is just going to get the process ID, and we're going to give it the window that we just got, and then it'll give us the process ID. So we'll store this as a reference to proc ID. Alright, next let's define our module base. So we're going to use that function called get module base address that we actually pasted in above. And for this, we're going to be doing the client_panorama.dll because this is where all the things we're going to be referencing are located. And next we'll make a uint pointer and we'll call this buffer. We'll use this later in the code. Alright, so we'll do a while loop right here. And in this we're going to do exclamation point. The exclamation point means not. So as long as we do not press the key VK underscore end, and you can replace this with whatever you want, like VK underscore shift, the shift key, or things like that. There is actually, you can search up virtual table or virtual key table to get the whole list of things you can put in here. But as long as we don't press the end button, the code will run. So the end button is essentially our exit button. Alright, so we're going to do uint pointer underscore t. And we're doing this because we are going to define our local player, declare and define our local player. So we're going to use this RPM, read process memory function. And again, we're going to make this a uint pointer underscore t because that's what that is going to be as. So we'll do module base, the module base of this, the address of this, plus DW entity list. So this will just get our local player because we are the first thing in the entity list. Alright, next let's make an int and we'll call this flags. And now the way this flag right here works is it's, I believe, 257 if we're in the air and 256 if we're on the ground. But for flags we'll do equals RPM, the read process memory. And then we'll put int in here because this is going to be saved as an int. Local player, and we just made local player right here, so local player. And then plus the define that we made for flags. These defines just make referencing these hexadecimal addresses and offsets easier. Alright, next we're going to do a if. So if flags and 1. So this is going to be checking the flags, and if we can jump, it'll make us jump. So buffer equals 5, and then we'll do else buffer equals 4, and we need to put our semicolons in here. Now 5 and 4, so this is going to be used for the force jump to force our player to actually jump for the bunny hop. 5 will make our player jump and 4 is just normal. Alright, so we'll do if get async key state vk underscore space, which is the space bar. This hexadecimal value of 8000 is just going to be checking to make sure we're holding down the key. So while we're holding down the key, we are going to do WPM for write process memory, module base plus the force jump. So we're going to go to the location of force jump and we're going to replace it with whatever buffer is set of. Alright, now that we have all that done, we're ready to test our code. So you might need to come over to build and click build solution and go to the location at which it builds in the debug if you aren't an administrator, but I should be fine. I can click local Windows debugger and we'll let that build and then run. Alright, so let's test it. And it is working. So this was a pretty simple thing. We'll do more later in this series. And if you have anything that you want to add or you want me to make next, just comment it down below and I'll take it into consideration for the next episode in this series. Anyways, thanks for watching.